Have you ever looked at the night sky and felt a connection to something infinite? Something ancient and incomprehensible? Billions of stars, each one a distant sun, and around many of them, perhaps, their own worlds revolve. We, humanity, have made an enormous leap in understanding the cosmos. We've sent robots to Mars, peered into the very heart of distant galaxies, and even photographed the shadow of a black hole. It seems as though we're on the verge of unraveling all the universe's mystery. But that's just an illusion. The deeper we look, the stranger and more astonishing the world beyond our planet turns out to be. Today, we're embarking on a journey through 10 cosmic facts that won't just surprise you, but will make you reevaluate everything you thought you knew. Get ready, your mind is about to get a serious shakeup. Let's kick things off with what's both the most obvious and, at the same time, the most shocking. Fact number 1. Space is unimaginably empty. We're used to seeing pictures of scattered stars, nebulae, and galaxies that appear tightly packed. But in reality, if you could magically zoom between stars, you'd fly for hours, days, even years, through absolute impenetrable darkness, seeing absolutely nothing. The average density of matter in the universe is roughly 1 hydrogen atom per 4 cubic meters. To give you an idea, imagine a room the size of a small gymnasium, and in that entire space, there's just one tiny atom floating around. Everything else? Just vacuum, pure emptiness. Even within our solar system, which seems to us teeming with planets and asteroids, the distances between objects are colossal. If you shrink the sun to the size of a grapefruit, the Earth would be a grain of sand, orbiting at a distance of 15 meters from it. And our closest star, Proxima Centauri, would be another identical grapefruit located 4,000 kilometers away. That's how alone we are. A small fact, the Voyager 1 and Voyager 2 probes, launched in 1977, have been flying for almost half a century, and they have only just now gone beyond the influence of our sun into interstellar space. This means we live on a tiny, warm, and noisy island amidst a silent and icy ocean of emptiness. If the void didn't impress you, then how about speed? We all know that the speed of light is the absolute limit. 300,000 kilometers per second. Nothing in the universe can move faster. Sounds incredibly fast, doesn't it? In just 1 second, light can circle the Earth 7.5 times. But on a cosmic scale, this speed is a snail's pace. And this is our second fact. The speed of light is depressingly slow. Light from our sun reaches Earth in 8 minutes. This means that if the sun suddenly went out, we would only know about it 8 minutes later. To Pluto, the dwarf planet on the edge of our system, sunlight already takes more than 5 hours. And to that very Proxima Centauri, the nearest star, 4.2 years. You look at it through a telescope and see what it was more than 4 years ago. The light from the center of our galaxy, the Milky Way, takes 26,000 years to reach us. And the light from our closest large galaxy, Andromeda, travels for 2.5 million years. When that light set out on its journey, Australopithecines, ancestors of humans, were still roaming the Earth. What we see through telescopes is not space as it is now. It is a giant time machine, where every object shows us its past. And this creates a fundamental problem. We will never be able to see the universe as it is at this very moment. We are trapped within our light cone, forever doomed to observe only the echoes of long past events. Alright, space is empty and slow, but it's full of treasures, right? Literally. And that brings us to fact number 3. There's a planet that is most likely 1/3 pure diamond. This isn't science fiction. The planet is called 55 Cancri E, and it orbits a star in the constellation Cancer, just 40 light years away from us. It belongs to the class of super-Earths, meaning it's rocky, like our planet, but roughly twice as big in diameter and 8 times more massive. Its main feature is its incredible closeness to its star. A year there lasts only 18 hours. Because of this, the temperature on its surface reaches 2,400 degrees Celsius, hot enough to melt iron. Astronomers believe that due to the immense pressure and heat deep within its core, as well as the large amount of carbon in its composition, a significant portion of this planet's mantle has transformed into a gigantic diamond. Imagine a world where mountains and entire continents are made of the hardest mineral we know. However, extracting these treasures would be impossible. Even if we could fly there, the monstrous gravity and hellish temperatures would incinerate any spacecraft in fractions of a second. So, this cosmic jewel will forever remain just a beautiful and tantalizing idea. But extreme conditions don't just create strange planets, they also give rise to utterly unimaginable objects. Brace yourselves, because fact number 4 is about to completely redefine everything you thought you knew about matter. We're talking about neutron stars. These are what's left behind after a massive star, one far bigger than our own sun, explodes. When such a star dies, its core collapses under its own gravity with monstrous force. Protons and electrons are literally smashed into each other, forming neutrons. The result is a sphere with a diameter of just 20 to 30 kilometers, about the size of a large city, but with a mass 1.5 to 2 times greater than that of our sun. The density of this material is so extreme that it's impossible to describe it in everyday terms. 1 teaspoon of neutron star material would weigh about 6 billion tons on Earth. That's the weight of 900 pyramids of Cheops. And if you took a piece the size of a sugar cube, its mass would be equal to the mass of all humanity. Gravity on the surface of such a star is hundreds of billions of times stronger than Earth's. If you dropped a marshmallow onto it from a height of 1 meter, it would hit the surface at a speed of 7 million kilometers per hour, and with the energy of an atomic bomb. And as the cherry on top, many neutron stars spin at breakneck speeds, making hundreds of rotations per second. These are the fastest, densest, and strangest objects in the universe that we can observe directly. One might think, what could be stranger than a neutron star? Just what we cannot see. Black holes. And fact number 5 isn't about their gravity, but about their sound. Hold on a minute, you might say. There's a vacuum in space. Sound can't travel there. And you'd be absolutely right. Sound as we know it is vibrations of air or another medium that our ears detect. Sound cannot exist in a vacuum. However, in 2003, astronomers observing a galaxy cluster in the constellation Perseus made an astonishing discovery. At the center of this cluster lies a supermassive black hole, and emanating from it are colossal waves within the surrounding hot gas. The black hole periodically expels powerful jets of particles, which create ripples in this gas just like a stone dropped into water. These pressure waves are, in essence, sound waves. It's just that their frequency is incredibly low. The lowest note scientists have ever recorded is 57 octaves below middle C on a piano. The human ear would never be able to hear it. To translate this cosmic music into an audible range, NASA specialists had to boost its frequency by quadrillions of times. And that's when they heard a chilling low hum, the voice of a monster living in the heart of the galaxy. So, while space itself may be silent, its most massive inhabitants certainly know how to sing. From sounds in silence, let's shift to movement in the void. We know our Earth revolves around the sun. The solar system, in turn, orbits the center of the Milky Way galaxy at a speed of about 220 kilometers per second. Our entire galaxy doesn't stand still either. It flies through space, being drawn towards neighboring galaxies, such as the Andromeda Nebula. But that's not all. And here's fact number 6. Our entire part of the universe is being pulled towards something gigantic, invisible, and mysterious. Scientists have named this object the Great Attractor. It is located about 250 million light years away from us in the direction of the constellations Norma and Triangulum Australe. Our galaxy, the Andromeda Galaxy, and our entire local group of galaxies are hurtling towards this point at a speed of more than 2 million kilometers per hour. What is it? We don't know. The problem is that the Great Attractor is hidden from us by the plane of our own galaxy, which is filled with dust and stars, making direct observations virtually impossible. It is hypothesized that it is a massive supercluster of galaxies possessing colossal mass. But its exact nature remains one of the greatest mysteries of modern cosmology. We are flying through space, obeying the gravitational pull of something we can't even properly see. The mysteries don't end there. If the Great Attractor is an anomalous concentration of mass, then fact number 7 will tell us about its opposite. an anomalous void. Imagine a map of the early universe. Scientists created it by studying the relic radiation. That's the light left over from the Big Bang, which uniformly fills all of space. It's a kind of baby picture of the universe. And on this picture, which is generally very uniform, there's one giant cold spot. It's called the relic cold spot or the Eridanus supervoid. It's a region of the sky that is inexplicably colder than its surroundings. Its size is astonishing, about 1,800,000,000 light years across. One of the main theories states that it's a gigantic void, a region of space where there are virtually no stars, no galaxies, and no dark matter. If so, it's the largest structure ever discovered in the universe. According to some more daring hypotheses, this cold spot could even be a bruise from our universe colliding with another parallel universe. Of course, these are just speculations for now, but the very existence of such an anomaly challenges the standard model of cosmology and hints that we still don't understand a great deal about how the universe works. All these mysteries, the great attractor, the cold spots, are within the confines of what we can observe. But what lies beyond the horizon? And this brings us to one of the most fundamental and mind-blowing facts. Fact number 8. We will never see the entire universe. What we call the universe is actually just the observable universe. Since the universe has existed for a certain amount of time, about 13.8 billion years, light from the most distant objects has only had time to travel that far. Thus, we are surrounded by a kind of event horizon. Everything beyond this horizon is beyond our reach. Light from there simply hasn't reached us yet. The diameter of the observable universe is approximately 93 billion light years. Why is it so vast if its age is only 13.8 billion years? That's because space itself is constantly expanding, and while the light was traveling towards us, the objects that emitted it have managed to recede even further. But here's the crucial point. We have no reason to believe that the universe ends beyond that horizon. Most cosmological models suggest that it's much larger, perhaps even infinite. Imagine you're on a boat in the middle of a boundless ocean. You see water stretching to the horizon, but you know that the ocean continues beyond it. It's the same with the cosmos. We live in a small bubble of the visible world, floating in an infinite, we assume, ocean of space-time, which we will never be able to fully explore. And now, let's talk about what this entire vast picture consists of. We see stars, planets, galaxies, nebulae. All of this consists of ordinary baryonic matter, protons, neutrons, electrons. The same matter that makes up you and me, our home, our planet. So here's fact number 9, and it's perhaps the most crucial of them all. Everything we can see, everything we could ever hope to touch and examine directly, accounts for less than 5% of the universe's total mass and energy. 5%. So where is everything else? Roughly 27% is accounted for by what's known as dark matter. It's a mysterious substance that doesn't emit or reflect light. We can't see it. We only know it exists because of the gravitational effect it has on visible matter. It's dark matter that prevents galaxies from flying apart and forms giant structures throughout the universe. We have no idea what it's made of, but that's not all. The remaining 68% is dark energy. This is an even stranger thing. It's a hypothetical force, evenly distributed throughout space, that possesses anti-gravity. It doesn't attract, it repels. It's dark energy that causes the universe to expand, and what's more, at an accelerating rate. So, to sum it up, 95% of our universe is something dark, invisible, and utterly incomprehensible to modern science. We are like people trying to study the ocean, only able to analyze the foam on the waves, knowing nothing about the water, the currents, or its deep-sea inhabitants. We began our journey from nothing, and we'll end it with silence. Eternal silence. Fact number 10 is a prediction about the end of everything. The universe had a beginning, the Big Bang. And that means, most likely, there will also be an end. There are several theories, but the most probable, based on our current knowledge of dark energy, is the so-called heat death, or Big Freeze. Since the universe is expanding at an accelerating rate, galaxies will move farther and farther apart from each other. faster and faster. In 100 billion years, all galaxies, except for those within our local group, will vanish beyond the cosmological horizon. The night sky for our distant descendants will become virtually empty. Then, over trillions of years, the last stars will fade away. Old stars will cool down, turning into black dwarfs. New ones will cease to form because the gas reserves needed for their creation will run out. The universe will plunge into darkness, populated solely by the cooled remnants of stars, neutron stars, and black holes. But even this is not the end. Even black holes are not eternal. According to Stephen Hawking's theory, they very slowly evaporate, emitting energy. After a googol years, that's a 1 followed by 100 zeros. Even the most massive black holes will have evaporated. And then, nothing will remain in the universe except a thin soup of elementary particles, photons, neutrinos, leptons, drifting in eternal cold darkness. No structures, no complexity, no life. Only emptiness, cold, and silence. This is the inevitable end towards which all existence moves. From the void between atoms to the void at the end of time. We have journeyed through diamond worlds, super dense stars, singing black holes, and the unseen forces that govern the cosmos. These 10 facts are more than just a collection of intriguing data. They are 10 brushstrokes on the gigantic canvas of reality, revealing just how limited our intuitive understanding of the world truly is. We live on a tiny speck of dust within the thin film of the biosphere, in one of hundreds of billions of galaxies, and yet 95% of the world around us remains a complete enigma. This can be frightening. It can make us feel insignificant. But there's another perspective. The universe doesn't have to make sense to us. It doesn't have to be cozy or make any sense. But the very fact that we, a handful of stardust descendants of exploded stars, can lift our heads, look at this boundless ocean, and start asking questions. The very fact that we can study it, discover its laws, and marvel at its beauty. That is the greatest miracle. And as long as this curiosity lives within us, our small journey through the universe will continue.